Algebra lesson 4-6, continuing our theme with graphing. And now that we've spent some time and we've worked with x and y intercepts, we've made input-output tables, we've also looked at slope, we'd actually like to kind of take all of this and put it together in a form that actually is a little bit easier, known as the slope-intercept form. This is a very, very popular, well-used formula for algebra. It's very basic, very simple, tells us everything we need to know, makes graphing very easy. Y equals mx plus b. That's the generic form for slope-intercept form. It's got a very unique name, and the reason it's called slope-intercept form is because those are the two pieces of information that we're actually given. We are given the slope, which we know as the letter m, and something new that's being introduced is the intercept, specifically the y-intercept right here is b. You may have noticed on some of the past problems that you've worked on in a discovery aspect that by substituting, if you wanted to find your y-intercept, we know we're supposed to plug 0 in for x. Putting a 0 in for x makes 0 times m become 0, and all you're left with is this number. The y-intercept would then be this number, which is nice, but we don't have to take that step anymore. We automatically know when it's in this form, we have what we call slope-intercept form. It gives us everything we need to know. We can start here, we can graph that very easy on the y-axis, and then the slope, which we write as rise over run, tells us where to go from that y-intercept. Alright? Parallel lines must have the exact same, or at least equal, slope. And what I mean by that is when we look at slopes, and we say, okay, line 1 has a slope of 2/3, then line 2 has to also have a slope of 2/3. But you might not always see the exact same fraction. It's possible that you could have line 2 equal -2 over -3. Even though those aren't exactly the same in appearance, they are the same in value. They're both equal to each other because a negative divided by a negative makes a positive. You might have line 2 with a slope of 4/6. But 4/6 simplifies down to 2/3, so therefore they are the same. But if you see something that has line 2 that is 3/2 for a slope, then that would not be the same. And you might say, yeah, but it's got the same 3 and the same 2, but that's not the same. Rising 2 and a run of 3, going up 2 and right 3 is not the same as going up 3 and only right 2. Those are different slopes. So these were parallel here, but this one is not parallel, so this would be no good. We don't want one like that. Okay, so our first example, and remember we're talking about slope-intercept form here. Write 3x plus 4y equals 8 in slope-intercept form. In other words, we need to play this shuffling game as much as we can until we can get this form, slope-intercept form. Remember, y equals mx plus b. And if you'd rather write it as a lowercase b, that's fine. Alright, y equals mx plus b. This does not quite look like y equals mx plus b. What's special about slope-intercept form is which variable is completely alone. The y value. We need to get the y variable all by itself. So we can play the shuffling game until we can get it alone. So what two pieces of information do you need? You end up needing the slope and the y-intercept, which means we must get the y value all by itself. So let's try that out. 3x plus 4y equals 8. We've practiced for quite some time getting and playing the shuffling game. If we want to get the y's alone, it means we have to get rid of these positive 3x's. The opposite of a positive 3x is the negative 3x. And we add 1 to one side, we must add it to the other side. Those cancel out. You now have 4y is equal to, since it's addition, we can put this in any order we want because you can add in any order you want. So I'll put it in front. That just makes it look more like the mx plus b that we've done in the past. Last step, got to get the y's completely alone. So we divide by the 4. Now you can leave it as y equals the negative 3x plus 8 over 4, or you could use the heart-shaped division and you'd actually turn it more into the slope-intercept form. Look, we're used to. Y equals, you can't really take negative 3 and divide it by 4, so you write it as a fraction. Put your x on there, and then 8 over 4 makes 2. Now what's nice is you have y equals m, which is a slope rise over run, x plus b, which is your y-intercept. Everything you need, slope-intercept form. graph negative 2x plus y equals 5, and the question right I have over to the side is, what is the slope? We're going to make this graph, but we're first going to change this into slope-intercept form. Because if we can get it into slope-intercept form, it makes graphing much easier. So in slope-intercept form, y is all by itself. Therefore, we'll add 2x to both sides. Because it's addition, we can add in any order we want, sticking the 2x in front of the 5 if we'd rather. Y equals 2x plus 5. In other words, y equals mx plus b. We now have it in slope-intercept form. So according to this problem, we know that m is the 2. The question I'm being asked right here is, what is the slope? We would say m is equal to 2, or 2 over 1, which is nice as a fraction because then you have your rise and your run. So I come over here and I look and I say, okay, we know that this is the y-intercept. So that's my y-intercept right there. Not the greatest arrow. Y-intercept. So I'm going to go up the y-axis 5 units. 1, 2, 3, 4, 5. And I'm going to put a dot there. One of the biggest mistakes people make is they put that y-intercept on the x-axis. It's the y-intercept. You must know where the y-axis is. It has to go on the y-axis. Next, I'm going to use this slope. Another big mistake is people go down to the origin, they go up to and over 1. That's not where you want to go from. You want to go from your y-intercept. The y-intercept is on your graph, and the slope is supposed to be a representation of your graph. So continue going up 2 and over 1, up 2 and over 1, up 2 and over 1, and do this as many times as you need to until you're sure that you're creating a nice straight line. What's nice about 2 over 1, it's also the same as negative 2 over negative 1. So sometimes if you feel like you're taking yourself off the graph and you have more room down below, change both signs. So now I go down 2, left 1, down 2, left 1, down 2, left 1. It won't matter. It still creates the exact same graph, which is right here. And if you'll notice, I still have my y-intercept where I started this, because that's where I have right here, y-intercept, and my rise over run tells me where to go from there, creating a graph. Could you still use an input-output table? Absolutely. Could you still use an x and y-intercept? Absolutely. But the y-intercept would be easy to find by plugging 0 in for x, but plugging 0 in for y, I would then have to solve, and I'd come up with a decimal, and notice it's crossing not exactly at a nice point. It's actually crossing at negative 2.5, which would make sense. If you stick 0 in for y, negative 2 times negative 2.5 is going to make positive 5, so it does work. It still matches up. Input-output tables, x and y intercepts, slope-intercept form. You now have 3 methods for making a graph. Last question, last example. Which of the 3 equations are parallel? In other words, which 2 have exactly the same slope? Now, I haven't given them to us in all the same format. None of these are in slope-intercept form, but they can all be made slope-intercept form if I just get the y value by itself. So I'll start on the right so I can work across the screen. In order to get the y's alone, I must add negative 12x to both sides. Delay. Those now cancel out. 4y now equals, since it's addition, I'll put the x's in front, plus 1. Just don't forget it's a negative 12x. We then divide by 4. And when we divide by 4, we end up with a heart-shaped division scenario. I'm going to take this right here and divide it by 4. So negative 12x divided by 4 is going to give me negative 3x. And I'm going to take this 1 and divide it by 4, which is 1/4. Now that's not a very generous or easy y-intercept. It's not the end of the world. But I'm not really concerned with the y-intercepts in this problem. I want to know which ones have the same slope. So I'm really concentrated on this negative 3. Hopefully one of these other 2 equations has that negative 3 for a slope, or the other 2 have the same slope, so that I know I have something that's parallel. Quick adjustment, plus negative 6x. Now I know I want to add 6x to both sides, so I can start getting the y's alone. They cancel out. 2y now equals, I can make it, put in front 6x because it's addition. You can add in any order that you want. Divide by 2, And we have the heart-shaped division here and here. Y equals positive 3x plus negative 5 over 2. Now again, I'm not concerned with the negative 5 over 2, even though that's the same as negative 2.5. What I am concerned is with this 3. And 3 is close to being the same slope as negative 3, but that's not exactly the same. So these two are not parallel to each other. I have one more to check. I'll make this a plus negative 5. Now this is actually a quick one, because I just have to divide by 3 and then y's alone. They cancel out. Heart-shaped division. I end up with y equals negative 9x divided by 3 is negative 3x. Negative 5 over 3 for my y-intercept. Again, I'm not concerned with the y-intercept. What I am concerned is that this negative 3 and that negative 3 are parallel to each other. They have exactly the same slope, therefore they are parallel. So a quick recap. Y equals mx plus b. The y is all alone. Everything else is on the other side. Your m value will be next to your x. M is your slope, and b stands for the y-intercept.